Good morning, everyone. It is an honor to be here with you at the 11th International Symposium Metrology 2021, organized by the National Bureau of Standards and the Metrology Research Institute of Cuba. I thank you for inviting me to this symposium of great importance to our region. Today I will talk about legal metrology in Argentina today and what we are doing to bring it up to date. I prepared this presentation together with engineer Leandro Garcia, our technical director of legal metrology. I will start by talking about the applicable regulations and details about the measuring instruments regulated in Argentina, our metrological controls and the actors involved in them, so you can have an idea of the amount of work that we carry out in the field of metrological control. Finally, I will devote a great deal of time to the new metrological control system that we are implementing, which includes the digitalization of our legal metrology processes. The current regulations in Argentina date back to 1972 with the law on metrology, and they make type approval and initial verification of regulated measuring instruments mandatory before they use. They also make subsequent verification and surveillance mandatory for instruments used in certain specific activities like commercial transactions, service assessment or supervision, public delivery systems, and others related, for example, to road safety. These are our regulated instruments in Argentina today. They include those used in trade and public service utilities, such as water, gas, and power meters, weighing instruments, taximeters, capacity measures, fuel dispensers, standard weights, oil meters, fixed storage tanks for fuel and oil, an important activity in Argentina, volume material measures, measuring systems for natural compressed gas, etc. Likewise, instruments used in healthcare, such as liquid and glass, digital, and mercury thermometers. The mercury thermometers are still regulated, but their sale is forbidden. And instruments related to road safety, like kinemometers, breathalyzers, and instruments to weigh the axle of a vehicle. We are studying other regulations likely to be approved in the near future for discontinuous, totalizing automatic wearing instruments of the arced chute type, very common for ship loading in seaports and very important for exports in Argentina, and instruments to weigh moving vehicles, that is, without having to stop them, to check whether they are traveling with excess cargo, and so on. We're also about to approve an updated set of regulations for scales in order to keep up with the present times. These are our metrological controls and the actors involved in that work. Type approval, which involves INTI as the national laboratory in charge of testing, the Department of Trade that issues regulations and approves the types of instruments based on those texts. Recently, we discussed the inclusion of instruments covered by OIML certificates and the participation of other laboratories. As you can see here, after they are designated and audited by INTI and approved by the Department of Trade. Another process is the initial verification, which uses a similar system to the one I have just described. We also have a conformity statement for cases when the manufacturer or importer claims that the instrument has been already submitted to type approval. This replaces the initial verification, and to that end, the manufacturer has to be audited and authorized by INTI before they can issue a conformity assessment or a conformity statement. There is also a process called limited type approval for single unit manufacturing. All these processes take place before the marketing of the instruments, and there is what we call market surveillance, also under the Department of Trade, although INTI can also conduct inspections as instructed by that department. Now, after the instrument is in the market and being used, we have subsequent verification, as we all know, conducted during 6 months, once a year, or every 10 years. INTI is in charge of them in Argentina. There are verifications after any repair work, and we have a system to authorize those service workers to repair an instrument and carry out a provisional verification afterwards. Then comes our process of surveillance while the instrument is in use through surprise, non-expected inspections conducted by either INTI or the Department of Trade, depending on how or where the instrument is used. In order to give you an idea of the extent of our work, I will talk about the annual controls that INTI performs for high-capacity truck weighing instruments. Well, these are figures of the year 2019 because of the pandemic. The years 2020 and 2021 were unfortunately a special period. So in 2019, we verified 4,300 high-capacity weighing instruments used basically for trucks, 3,500 medium-capacity ones, and 6,200 low-capacity scales, 49,967 liquid fuel pump hoses, 1,500 breathalyzers, 57 high-capacity storage tanks, and so on. Regarding INTI's infrastructure to carry out these controls, we have a truck with weights, 80 trucks with 20 tons of weights, owned by private service providers who participate in this work, always together with INTI. But contributing the testing instruments, we have semi-anechoic chambers for the tests required for type approval, 12 mobile units to verify fuel pumps, 4 laboratories across the country to verify breathalyzers, 25 vehicles to move our verification officers around, 120 qualified verification technicians, 25 engineers who participate in the type approval tests, a special laboratory for natural compressed gas testing, special equipment for the verification of oil tanks and meters, and a new laboratory for oil meter type approval. About what we call digitalization of legal metrology. Nowadays, we are all familiar with the classic verification process. You take the truck with the weights, The verification officer writes down the information about the standard instruments and checks that their certificates are still in force. And then they use an Excel worksheet to register the results of each measurement and make sure that the legal tolerances are not exceeded. And after that, INTI issues the relevant certificate, and so on. It's the usual method. And even if the technicians use a laptop to do this, there is a great deal of manual work involved. The new system that we are implementing will work in the cloud, and all the standard instruments will have a code that the verification officer can read directly with a tablet, and the system will verify the validity of the standard instrument. Then, when the verification officer uploads the results, a software program will make sure that the legal requirements are fulfilled and the tolerance is respected, and that the verification period has not expired. Whereas the software in the cloud will check that the instrument meets all the relevant requirements, and even that the verification was paid for before the type approval is granted, and the verification certificate is automatically prepared in the cloud for the user to download. This system will rely on references registered on a publicly available map and using different colors to make it clear whether the verification was valid or otherwise. The system will cover all the legal metrology controls that I have described here, from the type approval process to the surveillance while the instrument is in use and the verification after repair work. How will it work? For instance, for type approval and type warrant approval, the metrological characteristics of the instruments will be uploaded to the system together with all the relevant information for the file, including registration date, blueprints, etc. The system will make it possible to submit budget proposals for these expensive tests and type approvals. It will issue a work order, appoint a laboratory in each stage of the approval process, and keep a system of consultations with and statements by the manufacturer. This is very important in our line of work because it often becomes a topic of debate about what caused a delay in the process. So the system will keep an automatic record of these timings in order to establish who is accountable for what. Furthermore, the test report will be registered in the system, which will decide the kind, location, and level of the seals to be put in future controls. And of course, the system will issue the report and the invoice for that service. Then come the audits to manufacturers and repair workers, which, as I said, they need to make a conformity statement after the initial verification. The system will register the scope of the audit and the budget proposal, and will also prepare the work order, appoint auditors and dates to simplify the process. And it will also issue the audit report, the invoice, and the certificate. The same thing goes for the initial verification. The system will register all the relevant information, including the reports, a record of the seals, which is very important because the seal code of each instrument will be uploaded after every initial verification, and later on during the surveillance while the instrument is in use, the verification officers will be able to use their cell phones to check each seal reading through a QR code, and the system will let them know if the seal is indeed the right one that was placed during the initial verification, or if the instrument was somehow tampered with. The process is no different when it comes to the conformity statement. The system will not only appoint laboratories, make a record of the seals placed on the instruments, and register the report for the initial verification and the conformity statement of these instruments. The system will rely on georeferencing technology to store the geographic coordinates of the instrument's location. As to the subsequent verification, well, there will also be the usual process of budget approval, issuance of a work order, the appointment of laboratories, the registration of seals, and the georeferencing system. That is, all the processes that I mentioned before when we saw the picture of the cloud will take place automatically through the system to make the whole process much more transparent. The same goes for the surveillance process. The system will generate statistics that will help decide which instruments will be the object of surveillance through surprise inspections of the market. Verification after a repair work is a new process that will qualify service workers to make repairs between any two subsequent verifications. Except that in this case, the system will be more thorough in controlling this test. Based on the tests carried out by the repair worker, the system will establish whether the relevant authority should conduct a verification, taking into account the seals that were broken during the repair. And based on the location of those seals, the system will decide whether it is necessary to repeat the subsequent verification or not. Besides, the repair workers will have to use the system to check which seals they placed, since every one of them will have a special code to identify their own seals. In short, these are the general requirements of the system. It will facilitate the consultation of databases of approved types and seals to improve transparency in society, and not only for the sake of the authorities. It will be synchronized with the repository of digital signatures of the national state, as all the certificates will bear such digital signatures. It will also be synchronized with the Enterprise Resource Planning software, which INTI uses for its operations. Presea is a trademark of our ERP. It will have specific testing forms for each instrument designed through SGL. It will make it possible to select laboratories according to their specialty and coordinate the sequence of the tests, as well as the verification technicians in every province based on their availability and location. It will generate automatic statistics. It will give an alarm signal when a verification period is about to expire, and immediately send an email to the users to warn them that they must request a subsequent verification before the date of expiry, and make the relevant authority aware of the situation, marking the instrument in yellow on the map. It will also use georeferencing of the fixed instruments, so that as soon as the verification officer reaches the relevant location, the system can detect the instrument using GPS technology. And an important detail is that it will facilitate interacting with all the stakeholders in addition to INTI, the user, the local authorities, the Department of Trade, the service workers, the manufacturers, etc. will also be able to participate in and use the system. These are some of the forms of this instrument. For example, this one is for a platform capable of receiving a rolling load that is capable of weighing trucks. The process implies that you gradually check all the necessary tests, such as verifying the transition speed, verifying that the indication matches the travel distance, the different fees to pay, and so on. These documents will be digitalized in the system. The work order, all the documents provided by the user with a view to metrological control, such as a technical description of the instrument, INTI's report, the invoice, the certificate of validity of the subsequent verification, etc. So all the documents necessary for the operation of the system will be digitalized. What are the benefits of all this? Well, first of all, it will make it possible to streamline the metrological control processes and make it more efficient. It will facilitate a better use of resources. It will allow for supervision policies based on statistics or on georeferencing technology. It will provide more information about the dates of expiry of the instruments. It will highlight cases of non-compliance so that supervision can be properly focused, and it will contribute to define the impact of legal metrology on the country, since all the digitalized information will simplify the calculations. It will also make it possible to collect evidence about any non-conformity through warnings, mandatory photographic recordings, etc. And it will contribute to total traceability of the supporting legal documents, which are in printed form nowadays and therefore make our work very difficult. Furthermore, it will be an open platform, so it will be easier for other control mechanisms like customs, for instance, to learn about the current status of the instruments they use. And it will make control more visible, since the citizens will also be able to enter the system and check these maps to find, for example, which fuel dispensers are closer to where they live and whether their verification status is still in effect. It will also facilitate the possible adaptation to control systems in other countries, like the Inter-American System of Metrology, to promote cooperation in the field of legal metrology, considering that there are many initiatives to this end. It will also make it possible to carry out a simpler technical assessment for the recognition of type approval tests. In short, this process to digitalize legal metrology will make all its processes more effective and transparent in Argentina. Right now, I would say that the system is 75% completed. Everything concerning type approval, the audits of the manufacturers, etc., is already operational. What we call the mobile part, for instance, on-site initial and subsequent verifications, is also making great progress, to the point that we expect this activity to be fully operational in just a few months. Okay, this is what we wanted to present to you. We are at your disposal in case you have any questions, either here or by email. My appreciation to my Cuban friends and colleagues for their invitation to participate in this symposium, which is so important to our region. Thank you very much, and again, I'm here if you have any questions.